We are now going to investigate the graphs other than cosine and sine. So we're dealing with their reciprocal functions, cosecant x, secant x, tangent x, and its reciprocal cotangent of x. We're going to start out by writing the values for sine, cosine, and tangent that we know from the unit circle. Now that we have the values for sine, cosine, and tangent filled in from 0 to 2 pi, we can use the fact that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent to fill in the values for these functions as well so that we can then go about graphing them. So I'm going to do that now. Here is the chart completely filled out with these 6 trigonometric functions and their values from 0 to 2 pi. I've written in red undefined when we do 1 divided by 0. And that happens for cosecant at 0 pi and 2 pi, as well as cotangent at 0 pi and 2 pi. And then it happens for secant at pi over 2 and 3 pi over 2. Feel free to pause this video so that you can copy those values down. When we talked about the domain for cosecant, we had those points when cosecant was undefined, and that occurred at multiples of pi. So whenever you have the value that the function can attain, we have asymptotes there. So I'm going to draw in asymptotes now. At pi over 4, cosecant was root 2, which is about 1.41. At pi over 2, the function was a value of 1. At 3 pi over 4, again it was root 2. At 5 pi over 4, the function was negative root 2. At 3 pi over 2, the function was 1. At 7 pi over 2, the function was also negative root 2. At pi over 6, the graph was 2. At 5 pi over 6, the graph was also 2. And then at 7 pi over 6 and 11 pi over 6, the graph was negative 2. Connecting this graph, we get a function that goes positive without bound, and then in between pi and 2 pi, the function gets larger and larger without bound. And notice how this function of cosecant sits on top of the sine function. So we have our asymptotes, and then every 2 pi, we're going to repeat this pattern. So I can do the left side of the graph as well. Now let's look at some of the characteristics of the cosecant function. We can identify the range. The graph has this range from -1 to 1, where y does not exist as a function value. It starts at 1 and goes up, or starts at -1 and goes down. The amplitude, remember, is how far a graph deviates from that central line. But this graph gets larger and larger without bound, and decreases and gets smaller and smaller without bound. So there is no amplitude for cosecant. The period is 2 pi, just like it is for sine, because the graph repeats every 2 pi. There are vertical asymptotes at every pi multiple, or n pi. When I'm graphing the cosecant function, what I like to do is graph the sine function and then graph cosecant on top of that, like you see here, just to maybe a rough sketch with dotted lines just to get a visualization to help me graph this. Now let's analyze the secant function. For the graph of the secant function, it's the reciprocal of the cosine function. So here you see graphed the cosine function. So what was the domain of the secant function? Well, it was 0 every time you had an odd multiple of pi over 2. Knowing that the domain of this graph can't be every pi over 2 odd multiple, those are our asymptotes. I'm going to draw some asymptotes now. Drawing the points that we have, secant at 0 is 1. Secant at pi is -1. Looks like it's kind of familiar to what was happening with the cosecant and sine. Let's continue. The secant of pi over 4 is root 2. Since cosine is symmetric about the y-axis, I could then say the secant of negative pi over 4 is also root 2. Secant at pi over 3 is 2. using symmetry.
Secant of negative pi over 3 is 2.
We can connect these points. Same values, but negative from pi over 2 to 3 pi over 2. I remember that secant is 2 pi periodic, and so I can repeat this to the right and to the left as well. What are our key characteristics then? Our range, it's the same as the range for cosecant. Y has to be greater than or equal to 1 or less than or equal to negative 1. There is no amplitude as the graph increases and decreases without bound. The period for secant and cosecant is the same as sine and cosine, which is 2 pi. There is symmetry about the y-axis since this function is even. Those are our key characteristics for the secant function.
Just like when graphing the cosecant and using the sine graph, I like to graph the cosine function so I can graph the secant on top of it.
I've given you a table with the key characteristics of cosecant and secant here. The tangent function is the sine function over the cosine function. And so there are issues whenever cosine is 0, which happens at pi over 2 and 3 pi over 2. This means that tangent is then undefined at those values. A function being undefined means we then have vertical asymptotes at pi over 2 and 3 pi over 2. Another thing to consider is that when sine of x is 0, then tangent of x is 0 because you're dividing 0 by anything. And this happens at multiples of pi. The domain of tangent then is everything except those odd multiples of pi over 2.
When the function is undefined.
What is the range? Well, we know that the graph goes through at y equals 0. And then we have common values of tangent are root 3 over 3, 1, and root 3. But let's look at the graph of tangent. Let's plot a few of those points and consider the graph. Here's the graph of the tangent function with our asymptotes at pi over 2, 3 pi over 2, all of those odd multiples of pi over 2. And our graph goes through at 0 when sine is 0, which is at 0, pi, 2 pi, negative 2 pi. At pi over 4, the graph is 1, and at negative pi over 4, the graph is negative 1. We have the square root of 3 positive at pi over 3 and at 4 pi over 3, and then it's negative at 2 pi over 3 and 5 pi over 3. We have the square root of 3 over 3, which is about 0.58, positive at pi over 6 and 7 pi over 6, and negative at 5 pi over 6 and 11 pi over 6. So we see that the range, the graph is increasing and decreasing without bound. So the range here is all real numbers. Amplitude, again, this graph is increasing and decreasing without bound. So there is no amplitude. What kind of symmetry do you think this has? Well, the graph is not evenly symmetric because it's not symmetric across the y-axis, but it is symmetric about the origin because it's an odd function. Remember, the only even functions are cosine and secant. And the period, remember, for cotangent and tangent is just pi. Let's use the graph of tangent to help us with the graph of cotangent. The domain of cotangent is different than the domain of tangent because sine is now in the denominator instead of cosine. So whenever sine is 0, there is a vertical asymptote for cotangent. So the domain is going to be all the numbers except when tangent was 0, which happened at multiples of pi. Graphing the common points that we had for cotangent in our chart above. Cotangent was undefined at 0 and at pi where we have our asymptotes, but cotangent is 0 at pi over 2 and at 3 pi over 2. Cotangent is 1 at pi over 4 and 5 pi over 4. Cotangent is negative 1 at 3 pi over 4 and 7 pi over 4. So far, aside from the zeros, it looks like the graph of cotangent is the graph of tangent, but let's fill in a few more values. The cotangent of pi over 6 is the square root of 3. The cotangent of pi over 3 is square root of 3 over 3. The cotangent of 2 pi over 3 is negative root 3 over 3. And the cotangent of 5 pi over 6 is negative root 3. Connecting these and adding a little bit of a curve in there, we see that the cotangent and tangent functions are similar, but they are reflections of each other. We then have that the range is all real numbers. There is no amplitude because the graph increases without bound and decreases without bound. The period, just like for tangent, is pi. The vertical asymptotes happen at the odd multiples of pi over 2. And there is symmetry about the origin for this.
Here is a table summarizing the key characteristics for the tangent and cotangent function graphs.
To graph the functions of tangent and cotangent, there are some guidelines to follow. To find an interval between two consecutive vertical asymptotes, you can, for
the graph of tangent,
solve the inequality between negative pi over 2 and pi over 2. And for cotangent, you solve the inequality between 0 and pi using bx minus c. Next, you want to plot your x-intercept halfway between the asymptotes that you find for that interval. Next, you want to sketch the general shape of the parent function between the asymptotes. If a is less than 0, don't forget to reflect it across the x-axis. Lastly, you can sketch an additional cycle if you like.